So, two big data types. Data is either qualitative or quantitative. It either fits in this top category where it's qualitative data, which is also called categorical data, or it's numerical data, called quantitative data. Numerical data can only be numbers. Categorical data, most of the time it's words, but it can have numbers in it. Like a good example is a person's social security number. We call that qualitative because it just describes a category of a person. You can't do any meaningful arithmetic with it. So if you think about the values and you can't add them up, subtract them, and things like that, if you can't perform meaningful arithmetic with the values of a variable, it's categorical. It's qualitative. If you can, if you can find like the mean or the median or something, if you can find the mean, things like that, you can add them and subtract them. It's numerical. It's quantitative. There's a couple others that come up, continuous and discrete, but maybe we'll talk about those in a bit. For the first question here, a chef keeps track of the temperature of his refrigerator in degrees Celsius. What level of measurement of data is this? So degrees Celsius is quantitative, so we're going to look down here at interval or ratio. Interval data is data that doesn't have a true zero. Zero stands for nothing, right? 0 degrees Celsius does not mean no temperature. So Celsius does not have a true zero. 0 in Celsius does not represent nothing. It does represent something. Okay. Ratio data, like Kelvin, would be an example of ratio data because Kelvin has a true zero. So we didn't talk about we talked about quantitative variables. We didn't talk about discrete or continuous. Okay. Once you've decided something is a set of numbers and you can perform meaningful arithmetic, meaning you can add them and subtract them, then it's quantitative. Once you've decided that it's quantitative, then you've got to decide whether it's discrete or continuous. Discrete is it doesn't mean quiet or anything like that, secretly. No, discrete means countable. There's a countable amount of outcomes, okay, or it's a result of counting, we should say. Continuous is usually the result of measurement, okay, where there's an uncountable amount of outcomes. Like an example of that would be like measuring somebody's weight. You could say 190 pounds, 190.2 pounds, 190.21 pounds. There's an uncountable amount of options there. Okay, so given that Justin is collecting data on reaction time, what type of data is Justin working with? So reaction time, those are numbers. You could calculate a mean reaction time. So that means it is quantitative. It's numbers you can perform meaningful arithmetic with. And now we've decided that it's quantitative. Is it discrete or continuous? Reaction time, unless we're counting seconds, that's countable if it's just seconds. But if we're thinking about like 1.23 seconds or 1.235 seconds, that sounds more like the result of measurement, continuous. Market researcher finds the price of several brands of fabric softener. What is the level of measurement of their data? Its price. So that's a number. You could calculate a mean price for fabric softener. So that means it sounds quantitative because it's numbers we can do some arithmetic with. Is there a true zero? $0 means no price. So there is a true zero. This sounds like ratio data. The explanatory variable is the variable that's causing the relationship to change. It goes on the x-axis. So like you're thinking about like the chirps per minute of grasshoppers. The time in minutes is one variable. The number of chirps that happen is another variable. Actually, maybe, how about temperature? Temperature would be better. If temperature is one variable, the degrees Fahrenheit, and then the other column of numbers would be the number of chirps per minute, surely the temperature is causing the change in the number of chirps per minute. If a bunch of grasshoppers decide they're going to go do some chirping, they're not going to change the temperature, right? So the explanatory variable there would be the temperature. The response variable is the amount of chirping that happens, because the temperature is what causes the relationship to change. So Rebecca is investigating if height has any effect on red blood cell count. What's the response variable? So one column of numbers is height. Another column of variables is the amount of red blood cells. you wouldn't expect the red blood cells, like more red blood cells, to cause a person to be taller, right? I think that what the cause and effect we're thinking here would be like the taller a person is, the more red blood cells that they have. That's still a tricky one, because maybe you could think of it as the other way. Maybe the amount of red blood cells helps a person grow taller. But my guess is that they're saying height is causing red blood cells to change. So the response variable would be red blood cells. Height is causing the change, so that means red blood cells are the response variable. So which of the following best describes the term explanatory variable? The dependent variable in experiment, a value or component of. So I guess this hasn't been said yet. The response variable is also called the dependent variable. An explanatory variable, that's often called the independent variable. Okay, because the explanatory variable is the thing that's explaining the relationship. It's independent of the response variable. It doesn't care what the response variable is doing. Like the example, temperature and the number of chirps. Temperature is not going to be impacted by the number of chirps of grasshoppers, right? So it's independent. The chirps per minute is probably dependent on the temperature. So we're asked for the explanatory variable. That's not the dependent variable, that's the independent variable.